Hey everyone, my name is Jacques, and I've been working with computers ever since I can remember. This is me when I was just a few years old. And when I was 11, I first played around with basic HTML and JavaScript, and then later moved on to the hottest tech of the day, PHP. And I remember finding it pretty magical that you can have a server generate and serve a dynamic HTML page, and that you could interact with it by submitting forms and passing query parameters. But I think it's safe to say that the web has come a long way since then. I now work at Names and Faces as a senior full stack engineer. And at Names and Faces, we solve a problem experienced by everyone from the CEO to the intern. How do I get to know the people around me? How do I get context for where they fit in? And how do I get in touch when I need to? And we do this by offering a world-class employee directory available on web and as a mobile app. And we're backed by Y Combinator and Axel Ventures, and we've already got over 150 companies that use our product. Our current business model and systems are built around onboarding clients individually, so like kind of an enterprise sales model and service model. So typically a potential client would reach out to us, or we would reach out to them, and we'd go through a manual sales process and would set up the client's directory for them. But our goal has always been to move to a self-serve model where anyone could visit the Names and Faces website, sign up, and have a basic directory up and running in 5 minutes. And this would allow us to scale and make our directories available to anyone, not just companies. So after going through Y Combinator and being funded, we decided to finally do it. So we had to make a decision. Do we extend our current tech infrastructure to accommodate a self-serve model, or do we use this as an opportunity to start fresh? And we chose to start fresh for a few reasons. So firstly, our current tech is built around the enterprise sales and service model. So it's got some super complex logic for custom setups. And our current tech has pretty much existed since the beginning of the company. And while the tech is very sound, it wasn't necessarily built with team scale and flexibility front of mind. Because in the early stages of a startup, when uncertainty is high, the most important priority is usually getting features out the door now, right? But we wanted a clean slate so we could rebuild our tech with different goals in mind. Namely, we wanted to build code that scales with time and scales across a growing team and growing feature set. This was especially relevant because we were about to increase our dev team from a team of 3 to a team of 8. And we also wanted to build code that allows us to iterate fast. Our code shouldn't stop us from experimenting because we didn't know exactly what a self-serve Names and Faces would look like. And finally, we wanted to reduce user-facing bugs and errors. And we also felt that better technologies now existed that could help us accomplish these goals. And my inner developer was pretty chuffed about this because it meant that I had a couple of weeks all to myself playing with and evaluating a bunch of exciting technologies and help decide which ones to go for. That kind of sounds like developer heaven to me. And after a couple of weeks of experimenting and evaluating, we ended up choosing React, TypeScript, and GraphQL as the core, like foundational technologies for our new front end. And now that I've worked with these technologies for almost a year, and React for much longer than that, I wanted to share how they work, and not just how they've helped us, but how they can help development teams of any kind rapidly build and scale their front ends. Now, I can appreciate that different teams have their own unique challenges and situations. Not everyone gets to start fresh like we did. But I don't think it matters whether you have an existing project or whether you plan to adopt just one of the technologies I'll be chatting about. I mean, even if you don't end up using any of this tech at all, there are still some great concepts and patterns that can translate to other technologies, and even technologies that live outside the front-end world. And of course, there are upsides and downsides to these technologies, and they might not fit everyone, but we'll get to that a bit later. But my only hope is that you walk away from the session with more insight into these technologies and the reasons they can be so powerful. So for our new front end, we ended up staying with React, which we use in our current system, and we're very happy with it. React is a JavaScript library for building user interfaces. It's maintained by Facebook, and according to the Stack Overflow developer survey, is the most loved framework. And what sets React apart is that it's super lightweight. And that's why it's called a library and not a framework. It focuses on one thing, and that's building your UI, right? It provides an API to you to declaratively describe your UI, and then renders that UI efficiently and reliably. And it doesn't care how you manage your state or how you route users around. That's all up to you. Your React code base is made up of various components that are composed to build your UI. On the left here, you can see that we have some components that we wrote ourselves, a heading component and a modal component. These aren't actual components in our code base, just some examples. And on the right are two other examples of components, but you can imagine that these might be imported from a library. So the one is a date picker that might render like a calendar where you can click on a date, and that will give us a date back, and we can then log it out or do whatever we want with it. And the other is a route component that forms part of a routing package. And you might think this looks an awful lot like HTML, and you aren't wrong. This is React's way of using your components, and it's a language called JSX. So JSX is JavaScript, but with an XML syntax on top of it. And it gives us an ergonomical and like logical way to use, stack, and compose our components. So for example, without knowing JSX, I'm pretty sure you can assume that the div that contains hello world that we've passed into our modal is going to show up in the modal, because that's how it works in HTML, right? And we have a logical hierarchy of like composition where you can see that the div is inside the modal because it's wrapped in it and it's indented. And that's what makes XML and HTML so great, right? And the other powerful part of JSX is that it's just JavaScript plus a bit more, meaning you have the full feature set of JavaScript in your JSX file. And we're going to have a look just now around how that looks and works. But the idea is that instead of separating your logic and markup by separating the tech used to build them, you rather separate your concerns and keep your logic and markup together. So here's an example in Angular. So for a single component in Angular, you'd separate out the code by what technology that part of the code's written in, right? You have your business logic in one file, your template in another, and your styling in another. But in React, everything is written in JavaScript. For our button component, we declare the business logic, the markup, and the styling in a single file. And this is great because it encourages you to think about separating parts of your code according to what it's responsible for and not according to the technology it's written in. And this is how you define a component in React. It's just a function. Like you can see here, we have a function called button, and it takes in parameters, and React calls these props. In this case, we're pulling in onClick and label. We're taking that in. And we're returning a React element. So you might have a few questions by this point. The first is, what happens to the JSX before it hits the browser? Like surely the browser can't understand, HTML, like an XML-like syntax merged into JavaScript. Well, you're right, it can't, but it's actually just a very light layer on top of JavaScript. These JSX calls, so you can see this is apart from our previous component, that just gets transformed into a JavaScript function call. And that is returned from our button component. And the other question you may be asking is, when does React call your component function? Like, when is this actual button called, right? And what happens when you return, like what happens to the elements that you return from your component? Well, you can see here that when our component is first rendered, we use our component in JSX, and let's say we pass in an open modal label to it, right? What happens is React transpiles that or transforms that into a JavaScript function call. So you can see that we call react.createElement, which creates, and the first argument there is the name of the HTML element to create, which is button in this case. You can also pass in, if you're rendering a React component, that would actually be the component instance, but we'll get to that in a second. And the second argument are your properties or your arguments for that element. So in this case, it's onClick. And thirdly, it's what you're passing in as children to your component. In this case, it's a string that just says open modal. And then React creates the element for us in the DOM. So here you can see in our third step, React actually interacts with the browser and tells it, create this element, put it inside this other element, set its inner text to whatever we passed in, and add an event listener. But then if we pass through a new label on our second render, so we call our button component again with a different label prop, you can see that it goes through the first two steps in the same way. But in the third step, all it does is it figures out what changes need to be made in the DOM, in the browser, and it only makes those changes. So here you can see it only sets the inner text for that DOM element. And it knows which element to affect because it stores a reference on first render. And this is what makes React so great. You can describe your components in a declarative way, and then your whole render function is rerun, meaning you don't need to, number one, figure out which part of your component to rerun because it just all runs. And number two, you don't have to use the DOM's imperative API to build your UI, right? You don't have to go document.createElement button, etc. if you use methods like document.createElement or element.innerText, it'd be your responsibility to figure out what to change. But React does this for us. We can focus on describing our UI rather than figuring out which DOM methods to call. And making calls to the DOM is slow and it's a blocking operation. But because React optimizes calls to the DOM, it's actually very fast. And just a side note, a React component also re-renders when its internal state changes. But obviously, I showed you a React component, and it's just a function. And you might wonder how a function has state. Well, functions in React kind of have state, and we'll touch on that real soon. But we chose to stay with React because it's proven itself to be a scalable way to build UIs. It naturally encourages separation of concerns. You break up your code according to what it does and what it's responsible for. And we can build out all of these components that can operate independently of each other, and we can flexibly compose them depending on the UI we need to build. Not only does this mean we can reuse more code, but we can also easily remove code if we don't need it anymore. We simply delete the component and all uses of it. And the code also scales well across the team because developers can use a component written by someone else without having to dive deep into the component code. The component has a clear API of inputs and outputs. And because it's so lightweight and interoperable, we had the freedom to choose how we would do data fetching, authentication, routing, and more. We weren't tied to any specific framework's way of doing things. And this is one of React's core principles. All it does is provide a common abstraction for building a UI, and the rest is up to you. All of our existing code was written using plain JavaScript. And for our new system, we decided to make the move to TypeScript. So a quick intro to TypeScript. It's a strict superset of JavaScript. So any valid JavaScript is valid TypeScript. So if you take any snippet of JavaScript, pop it in a TypeScript file, it'll run just fine. So you can kind of think of it as JavaScript plus some extra stuff. And that extra stuff is static type annotations. And this means we can describe the structure of our code and data in a way that allows the TypeScript type checker to alert us of any possible runtime exceptions. But instead of alerting us at runtime, we get alerted at compile time. So instead of the error happening at runtime, meaning our user's app would break, we can catch them at compile time before these bugs even hit production. And I'm sure a lot of you have seen this error before. Cannot read property X of undefined. If you are a JavaScript developer, you definitely know this. And as a JS developer, it's probably the most common and most annoying error you need to deal with. And it's because JavaScript doesn't have static types, right? Anytime you access properties on an object, you have to be very sure about the structure of that object. So if I go, if I have an object and I have a property on it called example, and I go object.example, but that object is undefined, I'm going to get this error. But because we type our objects in TypeScript and all of our other variables, we don't have that worry. You can think of TypeScript's static types as a very sophisticated code linter, kind of like ESLint or code checker, which you help along by defining types. But the bottom line is that TypeScript isn't a wildly different language to JavaScript, but it's rather a thin layer on top of it with tooling around it. In fact, if you stripped out all the TypeScript type definitions, from a TypeScript file, the code would be 100% valid JavaScript. And in fact, this is one of the reasons we chose TypeScript. It's no different to the code we've been writing for years. The only overhead to learning is the additional type system. We also wanted a way to make it easier for anyone on the team to understand any part of the code. And TypeScript helps us immensely with this because types are a form of API documentation. Right? With our JavaScript code, for example, you often don't know what to pass into a function or what you're going to get back without diving into the function itself and looking at all the uses of the arguments and all the different code paths it can return. So TypeScript helps us fulfill our goal of a scalable code base, right? That checks our one goal. We also chose it because we were getting a lot of runtime exceptions, especially a lot of cannot read property X of undefined errors. And this has helped us dramatically cut down on those runtime errors. Again, check. Lastly, we wanted our code to be flexible to change without us breaking things. When I work on our old system today, I only now realize how much extra work I have to do manually following code execution to make sure my change didn't break anything. And this is true of all complex JavaScript projects out there, I'm sure. Again, another check. We decided to use GraphQL as our API layer as opposed to our Express-powered REST API that we have in the old system. And a quick intro to GraphQL, it's an alternative to REST, and it's nothing more than an open specification that describes how the client and server communicate. And although it's just a spec, there are a ton of tools around it, including a company called Apollo, which builds a ton of tools, and I'll get to that a bit later. But how it works is really simple. First, you define the structure of objects you want to query. So here you can see we have a to-do type, and it's got 2 fields on it. The one is an integer, the other is a string. And then we have a user type with an integer and 2 strings. So email and name are strings. And a user also has an array of to-do items. So you can reference one type in another. And then finally, we have our query type at the bottom, where we say that if you you're going to get a user back. Second, you query the data you need, right? So this is an example here in the middle of a GraphQL query. So we're saying that we want a user. It could return the current user. I'm not sure exactly how this API is structured. It's just an example, obviously. But let's say we want to query a user, and we want the email address back. And then we also want an array of all their to-dos, but just the label. So thirdly, you receive an object in the same structure that you requested. So here we're getting an object that looks exactly the same as our query. And so we can predict exactly what the structure of the data is that's going to come back. So your API structure is defined using what GraphQL calls an SDL, or schema definition language. And this is just a document that describes what can be queried from your server. And the structure of the objects that can be sent to it and returned from it. So your GraphQL API by design is strongly typed and self-documenting, because the entire API structure is already written out. And this ticked the boxes of our 3 goals. It's scalable because it's self-documenting. We no longer have to go trawling through server-side code to figure out how to interact with the API. And it allows us to rapidly iterate, and it reduces bugs because it's strong typing, gives us great developer tooling like autocomplete, the GraphQL playground, which I'll show you guys soon, and develop and compile time error checking. But I find it hard to get a proper sense for a tech without seeing it in action. So let's build something tangible using React, TypeScript, and GraphQL. So to do so, let's pretend for a few minutes. Let's pretend we're a developer working for a startup that's building a to-do list app. So after spending most of our funding on stocking our kitchen with Soylent and protein bars, as startups do, it's time to put the rest of the funding to good use and get our app launched. So we've broken the app up into various Jira tickets to allow our team of 6 to work on parts of the app simultaneously. So we're going to pick up the next ticket. And our ticket is now to assemble all of the different built components into the final app and hook it up to the server. So I'm going to start by just heading into my IDE. So I've got my IDE over here on the left, and what I just need to do quickly is reset things. And this is why live demos are terrible, because they always go wrong. So let's exit Zen mode in VS Code and just undo all the changes we made. So we're back to a clean slate. And that was my last minute practicing. So we have our app here on the left, and on the right here, we have our actual app displaying. So we have our VS Code on the left, which is, for those of you who don't know, is Microsoft's fantastic IDE that is partly written in TypeScript, and its autocomplete engine is powered by TypeScript, which we're going to see in action in a second. And then on the right here, we just have our little React app up and running. So if I make a change here, and I refresh on the right, you can see that my change pops up over here. So our first task for this ticket is to add our user component at the top. So let's do that. So I'm going to pull in our user component, and you can see that TypeScript actually automatically imported our user component because, well, rather I should say VS Code did it, but in the background TypeScript did it, because TypeScript knows our project structure and it knows all of the variables declared that are exported as modules. So I get my autocomplete, it pulls it in correctly from the right path, and you can see that we now have our user component brought in. But when the app reloads, you can see that we actually get an error, and it's saying property name is missing in type, but it's required in the user props type. So, and you can see the red line underneath my component as well. And that's because the developer who wrote this component added prop types to it. So if we go into the component, we can actually have a look at those. And we can see that here's our type, which is just a TypeScript type that we pass into our component. And it just says that we have one property called name, and its type is a string, right? We can see it here as well. If I open up my autocomplete, which is another VS Code feature powered by TypeScript, you can see that our name property comes in here, and we can ignore these two just because they're specific React properties that we won't touch on. But again, React's word for a parameter is basically a prop, right? So what's really cool about this is, it's one of the most impactful effects of TypeScript, being able to efficiently and automatically share knowledge across teams, and across developers in a team. So without needing to look at the file itself, I've been able to see how to use this user component, and my build obviously won't pass if I don't use this component correctly. And obviously I didn't write this component, someone else wrote it, and I have no idea how to use it until I actually look at the types. And if we didn't have the types, I'd have to dive into the code to see what's happening, or someone would have had to write manual documentation. Normally I'd have to go into the code, figure out which props can be passed, figure out which ones I need to pass. But with TypeScript, it's easily discoverable. It gives me autocomplete, and the correct use is enforced in our CI. And I cannot merge my PR if I have a type error, right? So that's how we have it set up on our side, is when a PR goes in to GitHub, we have a hook that fires off that runs type checking and will come back with an error if our type checking failed, which is really great. And that has eliminated a lot of runtime errors in our apps. So we need to pass in a name, obviously. So I've got my autocomplete, and I'm just gonna put some random string in here for now. And that looks good, right? It's rendering out our user component. But we actually want to fetch some data from the API. So I have my API running locally, and I can open up the GraphQL playground, which is served by our API. And I can go ahead and look at the docs section of our playground. And this is our API documentation. So just by building our API in GraphQL and assembling the schema definition language, that can be pulled out into some documentation. And this is a lovely interface for us to explore what our API can do, right? And I see I have one query available to me, which allows me to fetch a user. And if we were using a REST API now without any documentation, like without tooling like Swagger, I need to trawl through the code to find the right endpoint. And once I find it, I need to figure out the parameters to pass in and all the possible return values and response codes. But with GraphQL, you know exactly what you need to pass in and what you're going to get back. Now, I could write the query here in the playground because it has the benefit of autocomplete. But I actually have an extension installed in VS Code that gives me autocomplete right in VS Code. And obviously, my query is going to end up in my code anyway, so might as well write it here, right? So let's create our query. Let's call it user data. And I'm going to use this GQL tag, which again is auto-imported thanks to TypeScript. And this basically just tells, is a marker in our code that anything in this string is GraphQL. So I'm going to create a query. I can call it whatever I want. It's just a label for this specific query. And you can see that, again, I have autocomplete. So I have two GraphQL, like internal GraphQL queries here. The one is schema. And if I actually queried schema, I'd get my whole API schema back, which is quite cool. But I want my user, right? So if I select my user, you can see that I automatically get any required parameters filled in. So I need to pass something into where, and you can see that I need to pass in either email or ID into the where clause. So let's do ID1. And just a note here, this might look like I'm kind of writing something similar to a MongoDB query or a SQL query, but this is just how our GraphQL API is designed, right? GraphQL isn't a direct interface to your database. It's rather a spec that you can use to set up your API to work best for the front end. I kind of feel like REST APIs are optimized for the server, but GraphQL APIs are optimized for the front end, right? You can structure your GraphQL API however you want that works best for your front end, no matter how your database is structured. So if we didn't want this where clause, because obviously it's insecure because I can just change the ID that I fetch the user for, but obviously it's just an example. I can just have a current user query, which will just fetch my current user for me, or I can just call it user if I want to. So I can do whatever I want, right? Even though it might look more like a query to the database than REST would be, it's completely up to you how you want to structure it, right? Regardless of your DB. Anyway, so what I need to do now is I need to select from my user object which fields I want back. And for now, I just want name. But you can see again, we get our autocomplete. So let's pull that in. And now we have our query, which is really cool. And so with GraphQL, we need to specify what we get back, because by default, nothing comes back. In fact, it's invalid to not specify what you want back. And what's great about that is you can then choose just the fields that you need for your UI, meaning you reduce the response payload from the server and any additional work on the server to fetch related data or whatever. So now we can integrate GraphQL and React and actually fetch this data and pull it into our component. And we can do that through what React calls a hook. So let's import a use query hook, and we're going to pass our query in here. And you'll see that the response we get from this use query hook gives us the state of our query. So data, loading, and error. We can ignore error for now. I'm not going to do any error handling. But basically, hooks allow you to add additional functionality to your components. And what's really cool about hooks is they allow us to add state to our React components, meaning that this use query hook can cause this app component to rerun. So when this use query hook gets data back from the server, right, the loading, this function is going to run again, but the result here is going to be some new variables. So instead of loading being true, so actually, let me just log it out and we can have a look at that. So if I log out data and loading, right, and obviously for every line that we log, that we'll see a log for, is the component rerunning, right? So you can see that here we go. Here's all the different runs of the component. And you can see that the first run of the component, data is undefined and loading is true. But as soon as the data has loaded, this whole function reruns again. Data is our data and loading is false. So that's how you can add stateful logic to your React components. And it's a very simple way of doing it because there's no mutation involved. Whenever the state changes in your React component, everything reruns and you just get new variables within this closure. So let's add a loading state. So I'm going to say if we don't have any data or we're busy loading, I'm just going to return a div and just say loading. And again, you can see the power of React here. You can see that I get, by virtue of just using JavaScript logic, I can have different code paths here that I return, and it'll return different React elements. And depending on what's returned from here, React is going to add and remove DOM elements for me automatically, right? So now I can actually take my data and pass it in to name. So if I go data dot, I'd expect to get some autocomplete, right? That'd be really nice. But if I hover over data, you can see that data is actually typed as any, which is TypeScript's type for this can be anything, right? And that's because TypeScript doesn't know what the structure of the data is that's going to come back from this use query. But what we can do is we can use a tool called CodeGen to take our GraphQL types, because GraphQL is statically typed, and pull it into our TypeScript for us, right? So I can run yarn CodeGen, and what it's going to do is it's going to create a new file for me. So if I import user data, which is a type, and pass it to my use query hook, you can see that my data type is now defined as user data. And if I head in to look at what user data looks like, user data is an object with a key of user, and that user is another object that has a name field that is typed as a string, which is in line with what we get back from GraphQL. So now, if I go data dot, you can see that we get data.user dot name. Fantastic autocomplete, and again, error checking if I don't have the right code. So now we have shared types between our server and our client, which is super, super cool. Next, we need to display the list of to-dos. So let's import our list component. So let's do that quickly. And our list component, again, is just a generic component that can render anything. It can render any content. And let's say it's built into our UI library, right? So we need to pass a couple things. We need to pass, a couple props, data and render item. Let's pass through data. And data, if I hover over it, you can see that it's an array of some unknown type. So let's make it an array of strings, because just to test our list, I'm just going to render out this array of strings, right? And then for my render item prop, I need to pass in a function, and that function gives me one item, and that item, based on that item, I need to return a React element for that given item, and the list will then take this element and put it into the list for us, right? So this function over here is going to run for each item in this array, and it's going to take the element that's returned from it and put it into the list. And you'll notice if I hover over item here, it's typed as a string. And that is because I passed in an array of strings. And this is one of the most powerful features of TypeScript. It's TypeScript generics. You can think of them as parameters that you pass into types with inference, meaning if I type this list correctly, I can type it so that whatever I pass in here as an array, this type over here is a single item from that array, right? No matter what kind of thing I pass in here, which allows your types to be very, very flexible. So let's actually pull in our to-dos. For now, I've just returned a div it's just going to render out our item. Let me just open up my chat here. It seems like there are a few questions which I'll quickly jump to. Someone's asking, how would you mock GraphQL queries in Jest? Answer to that is there is tooling around that. You can mock them. There is a special mock provider that Apollo gives you. So just a bit of background on Apollo with GraphQL. So Apollo is a company that offers a full GraphQL toolchain. They're the industry leaders. So they provide a client API, which we're using now with this use query hook, and and they also provide a server, which is really cool, and they provide the code gen tool, and they provide this VS Code extension. Yeah, and then so I'm going to continue with the demo for a little bit more, and then head to some more questions at the end. But please keep them coming. Cool. So I've got my div rendered here for each item, but we actually want to fetch our to-do items. So what we want to do is fetch to-do items for this specific user, right? So normally with REST, we've got two options. One is we can add the user's to-dos to the user endpoint. So when you fetch the user with REST, you just get the user data back plus to-dos. But that means you need to either do that yourself or wait for a dev to do it, a backend dev to do it. But that also means you're overfetching data, right? If you have a user query and you fetch all the user's to-dos and return that as well, all the places where you're already using the user endpoint, or where you might use it, where you don't need those to-dos, that data is going to be fetched and returned unnecessarily, right? You can always add a parameter to conditionally return it, but that just becomes a mess. The second option is you can make another API call to just fetch to-dos, but that means two API calls, and you may have to do the calls in series if the to-dos endpoint depends on the result of the user endpoint, right? So if I only got the user ID from my first endpoint, and my second endpoint needed that user ID, I would have to wait for the one endpoint to finish responding, and then but with GraphQL, we can map out our data relationships. So if an object has a to-dos field, so our object has a to-dos field, right? Meaning we can fetch to-dos for a user, and we can see, again, we have autocomplete. So I'm going to fetch ID. Actually, don't need ID. So let's just fetch label and complete. Actually, I do need ID later. ID, label, and complete for our to-dos, right? Now I can simply run code gen again. And instead of passing in my array of strings here, I can go data.user. And I now have my to-dos object as well because of code gen. So now I've passed in my array of to-dos. And if I hover over item, you can see that the type is a single to-do item. So if I'm just going to rename it to to-do for clarity, and if I now go to-do dot, I get the fields that I queried on GraphQL, which is super awesome. So that's a combination of GraphQL, code gen, and TypeScript generics all working together to give me a really great developer experience. So now we can import our item component, which is used to render a specific to-do item. And what do we need to pass in? Well, we need to pass in complete, label, and onClick. So let's do that. To-do.complete, label will be to-do.label, and onClick will be just empty for now. But we are going to add some interactivity later on. But now you can see that our to-dos are rendering out just fine, which is awesome. Alrighty, so now we have our to-do items rendered out. Now that we have that, let's add some interactivity. So we want to mark the to-do item as complete or as incomplete when clicking on it. So reflecting data updates has evolved a great deal since static pages. In the beginning, we had static pages with forms, right, which posted to an endpoint. So you'd fill in a form, or you'd have like some sort of UI that's disguised as an HTML form that would submit to an API. The page would reload and you'd fetch all of your updated data, but everything else as well, right? But nowadays, what we do is we add custom state logic on the front end to hold on to data from the API, right? So in React, this means using a state management library like Redux. So we would make an API request, copy that data into our client-side store, and provide it to our components. And when we make an update, we listen for the API response, and then we update the local state to match the state of the API. And often this leads to a lot of API logic that needs to be duplicated on the client and needs to be kept up to date if the API changes. And Apollo provides a similar solution, but one that's way more ergonomic and automated. So let's see how this works. So I'm going to head back to our GraphQL playground. And you can see that I not only have queries, but I have mutations. And mutations are basically, you can kind of think of them as similar to a put or a post or a delete in REST. So it's basically anything that if you call it, will change something on the server side, right? So here we have one that's called update to do, and I'm just going to go ahead and use that in my code over here. So let's call our mutation update to do, and again it's going to be a GraphQL operation, and we're going to say this time that it's a mutation, and we can call it update to do, and we're going to use the update to do mutation, and you can see that we have two required parameters here. The first is going to be data, so what we want to update. So we're going to want to toggle the complete value, right? So I'm going to pull that in. And we want to update a specific to-do, so where the ID is whatever ID. Again, you don't have to structure your GraphQL like this. This looks very much like a DB again, but you don't have to make it look this way if you don't want to. You can do whatever is best for your front end, right? And then with our mutation, we're going to take in some variables passed in through JavaScript. So the one is going to be the ID, which is an integer, and it's required, which is why I have this. And the second is going to be complete, which will be a Boolean, and required again. Get that spelling right. Cool. Now we can choose what we want to get back from this mutation. I'm going to get back ID and complete. And the reason we need to specify what we get back from this mutation is because our mutation returns our updated to-do object. So we're going to tell it, mark our to-do as complete or not complete, and mark this specific to-do for this ID, and return the to-do ID and to-do complete. And you'll see how we'll use that in just a sec. So now we're going to use another React hook called useMutation. And I'm going to pass in my mutation. And again, I can run CodeGen, which is really cool. So I'm going to run CodeGen and pass in my CodeGen type. And now I have two types that I can pass in. The one is update to do, and the other one is update to do variables. Because we have some variables that we're passing into our mutation, we have this type now as well. And this hook gives us back a function that we can call to actually action this mutation. So let's do that. So let's call our function update to do. And this update to do function, we can just call it from our onClick. So let's do that. So let's call update to do. And obviously we need to pass in variables. And if I save here, you'll see that I actually get an error saying that this empty object is missing ID and complete. Because we set our variables as required, that's trickled through to TypeScript, and we're getting a TypeScript error, again, meaning that if we put this out as a PR, we would get a build failure and wouldn't be able to merge. So let's pass in our ID, which is going to be our to-do ID for this given to-do, right? So we're just taking this to-do item and getting its ID, and then we're going to set the complete value to the opposite of what it currently is, right? So if it's currently complete, so if this is true, it's going to flip over to false and vice versa. Now, if I save this, you can see my error goes away because I'm passing the right types in. And now when I click, this mutation runs, And interestingly enough, not only does the mutation run, but our data that comes back from our query over here gets updated with the new complete value. So even though I'm running my mutation, which is, we can trace this, right? So firstly, I run my mutation, right? That goes to the server and that says, okay, set this to do's complete value to this specific new complete value. And we can see what that looks like, right? So let's head into the network tab here. This might be a bit tough with a small screen, but let's see. So you can see that I tell it, I give it my mutation, and the response is my to-do, so the ID and the complete, the updated to-do object, right? And what Apollo is smart enough to do is it knows that we've just come back with a to-do item because this type name is included. So it knows that these fields reference a to-do item, and it knows that this is our unique identifier for that item. So what it does is it takes any other fields like complete or whatever else we might have changed, and it updates our local cache automatically. So any queries that reference this to-do will get the new updated complete value. So we don't even have to worry about when we get the API response back, we need to change our local state to update the complete value. So there's no duplication of client-side logic. There are a few cases where you do need to do some manual work, but for the most part, everything just works automatically, right? It's kind of like two-way data binding, but it's done in quite a functional way. So that is basically how GraphQL queries and mutations work and how it integrates with TypeScript and React. There are some other great features to all these technologies, but this is pretty much the end of the demo. But it was just a high-level overview of the tech, and there is much more to each of them than I could fit into this talk, so I encourage you all to dive deeper. And if this felt like a bit of a sales pitch, it's kind of because it is, because I wanted to reflect on our positive experiences with using these technologies and how they've enabled us to build UI faster than before. But as with all technologies, they all have their downsides, right? So now it's time for the anti-pitch. And there are a few reasons why you might argue against adopting these technologies. The first one is the overhead of learning these technologies, right? This is totally valid. There's always an overhead when incorporating new tech into a dev team, and it's something you need to consider depending on your situation. But in my experience, they're all relatively easy to pick up, especially React and TypeScript, because of how similar they are to the technologies they're built on top of. 4 of the new developers we hired at Names and Faces last year came from a Ruby on Rails background, and they had mostly worked on backends. And within a couple of months of working with this tech, they were fully comfortable with it. The second is adoption overhead, right? All of your code may be written in completely different technologies, so you may feel like you'd have to rewrite everything to adopt them and get the benefits of this tech. And that's not usually an option that makes sense for you, right? You could have spent years investing in your current tech and you don't want to just throw it all away. But thankfully, all of these technologies are interoperable with other tools and are incrementally adoptable. React is fully interoperable with other front-end tech. So you can start by writing only a few new features of your app with React if you want to. And it's also got escape hatches to do low-level, like imperative DOM operations. This also allows you to put non-React components inside React. So if you were brave enough to wrap a jQuery UI date picker as a React component, you could. And TypeScript is also incrementally adoptable, right? You can set up your project to allow plain JavaScript files, meaning you can keep all your existing code in TypeScript, or you can keep all of your existing JavaScript code and then add TypeScript when you write new code. So the benefit you'll get here from TypeScript will increase linearly with the percentage of typed files in your code base. So you'll get benefit from day one because you'll have your TypeScript project set up, your JavaScript still working as is, but because you start from then on to write new things in TypeScript, you'll get the benefits, and slowly you can migrate things over. And GraphQL is also incrementally adoptable. You can use it for new features only, but there are even tools where you can proxy your REST API through GraphQL if you want to do a slower migration, or if you just want to use GraphQL and want to keep the REST API going. But I hope my overview today has given you a better idea of how these technologies work and what they can do and how they can accelerate front-end development and what an adoption path might look like. if you're interested in learning more, check out the relevant React, TypeScript, and GraphQL websites. They all have fantastic documentation. I don't think I've ever seen better documentation than the React docs. And I'll also be writing a blog post based on this talk with some more info and nuance. I might split it up into various parts. So look out for that by following me on Twitter. And lastly, yeah, visit namesandfaces.com if you want to learn a bit more about what we do. And if anyone has any other questions now, feel free to ask them. Let me have a quick look here. Cool. Are there any specific extensions for VS Code that you highly recommend for someone working with a stack? Yes, there are a ton. Let me open up my, let's see what I've got actually. I can't quite remember what I have, but let's do this quickly. There we go. Let's have a look at my extensions. So I've got the Apollo GraphQL extension. Like I mentioned, this gives you syntax highlighting and autocomplete, like I showed. We've got a few other things related to our, a few other things like Docker, because we use Docker for our containerization. But then ESLint is great as well. Obviously, it's a tool, but it's also a VS Code extension. So it catches any oddities in your code that something like TypeScript might not even pick up. I've got Prettier, which is fantastic for JavaScript and GraphQL. So you can see, obviously, that I had quite a small VS Code window. And what I told Prettier was that if I have a really long line, it just needs to collapse it for me. So Prettier is really great. And that's pretty much what I have VS Code-wise. But there are a ton of other extensions. I always just look at the rating, and if it's a good rating and got high usage, then yeah, then I would just install it. What would you recommend Angular developers to start if they're interested in switching to React to prepare for a role with this stack? Honestly, I would go for the React documentation. So let's quickly head there. So if I go to, sorry, I'll show you my browser history there for a second. Let's see, React docs, search for that. So the React documentation is great. They've got a tutorial for building something in React. So if you like learning through a tutorial, go for that. It's amazing. But if you like learning from a more technical side, but still obviously in an incremental and not overwhelming way, you can check out their main concepts series of posts. And this introduces you to React slowly and incrementally, which is really great. How does useQuery set the internal state? I thought it would need to call setState. Correct, yes. It calls setState, but it uses the UseState hook. So I can quickly show you how this works, if you'd like. Let's open up VS Code real quick. And let's get it into where we had it and get into Zen mode. Zen mode, there we go. So for those of you who haven't worked with React State before, there's a hook called UseState, which is built into React. And let's have it initialize. It's the default value at 0. Again, I'm going to import it automatically. I get, so the question basically was around how does this trigger our actual component to rerun, right? How does making a function call within this function cause the function to rerun, right? So what I can actually do here is in React, I can have a UseState hook, and then I can return, let's return a div with a button, right? And when I click on this button, I'm going to do something. And in the button, I'm going to render out, sorry, my shift key, got a MacBook Pro and the keyboard's terrible. So what I'm going to do is I'm literally just going to render a button with our count value, right? But what I can do is I can call set count. So that'll be count plus 1. And what this is going to do is I'm going to call set count, which is going to update my state value, which in React internal logic is going to cause my component to rerun. And this value here, instead of it being 0, is going to be 1, right? On the next function call when it changes, because I'm going count plus 1. So on the first render, you can think of replacing this variable mentally, think of replacing it with 0, right? And then when I call this, obviously I'm going to call set count 1, right? And then you can think of this function, and then that render is done. That render is done. We just need to render again. So you can now again mentally think, this is replaced with 1, this is replaced with 1, this is replaced with 1. And then if I click it again, it's going to be 2, etc., etc. So this is how we can get, this is how we can store state within a React component, right? And that's basically what useQuery does, just in a more complex way. So it stores our data for us in state, and then when we fetch new data, or when we fetch data the first time, and when it comes back, it sets its loading state to false, and it sets the data state to whatever the data is. Cool. Does GraphQL have any disadvantages like optimization? Yes. GraphQL, so you can easily attack a GraphQL endpoint if you don't think about guarding against it. So there's a thing called query complexity in GraphQL. So because GraphQL allows you to fetch nested things, let me quickly head into the playground and show you, right? So I have a user query. So let's fetch our users, right? I'm going to fetch my users, and for each user, I'm going to fetch to-dos. And for each to-do, I'm going to fetch the user. Again, I'm going to fetch the to-dos and the ID for each. And you can see that that fetches a massive amount of nested data. And I can do that over and over and over again if I want to. Also, imagine if I have a users query here, and for each of the users that we get back, we return the to-do. We return a list of all the to-dos, right? What that means is I can write a GraphQL query that slows my database down incredibly, because what might happen if I'm not using the right like methods on the server to fetch my data from the database, which I'm going to touch on in a second, how this might work is I fetch all my users, I make a single query to fetch my users, then GraphQL goes and says, okay, I've got all my users, let's loop through that and fetch all the to-dos for each user, right? So that means n+1 queries, right? One query to fetch all the users, and n queries, which is the number of users, to fetch to-dos for each user. So if I have 10 users, I'm going to do 11 queries. So there are ways to optimize this in GraphQL. You can use things like data loader. I'd encourage you to just have a Google, check out what's around. But data loader helps with that. Basically what it does is it caches your GraphQL queries, it waits just a beat, and then it combines your queries to the database to make it more efficient. And then with query complexity and like kind of being able to attack a GraphQL query, there are very easy ways to guard that. There are ways to guard against a certain level of query complexity. Yeah. Would you create a new mutation to update the to-do label? No, I would probably do it all in one. So my mutation over here can actually take in, so if I go update to do, I can say update where ID is 1, and my data can include any one of these. So I can update any one. I can even update the user if I want to. That's how I've just set it up. But usually for us, how we do it at Names and Faces is you just pass in the object, and if you include so you just pass in the whole object, rather you pass in the ID of the thing you want to change and whatever other fields you want to update. And then as a result, you just pull in which fields you updated. And then the cache update works automatically. Does Apollo have helpers for handling authorization on nested objects in the GraphQL tree? For example, you want to limit access to the to-dos for a user. In a few seconds, sample code for demo. Yeah, so there's some simple ways to do that. Apollo has something called, the Apollo server and client have something called context. So your server, when it receives a query, can pull context from, let's see if there's an example here. So it can pull context from your query. And basically, so for example, what you can do is on the client side, you can, using context, let's quickly open up an example on the client side. Sorry, actually, let me do. Oh, this should work. Sorry. Okay, there we go. So here, what we're doing on the client side is we're adding an authorization header to any request that goes out to GraphQL, and our server can pick up on that because it's automatically sent within a resolver to context. So I can then just pull the authorization header off of it, and then I can build. How I build my logic is completely up to me. Another question, I'm fairly new to front-end development. How would you know when to use a REST API versus GraphQL? And if you were to use them together, what would that scenario be? It depends. It depends. I would suggest if you're new to front-end development, try both. I like GraphQL more nowadays just because of the spec that it gives me. I've always struggled with REST because I never know what like, if I get a response back, like if I create a to-do, what do I get back? Do I get a 200 saying that everything was fine? Or should I respond with a 201 saying that the item was created? So it's just, yeah, GraphQL is just way more straightforward and doesn't have as much guessing as REST, because REST isn't a spec. It's just like a convention, right? Yeah, so I would just check out both, but especially GraphQL. Is your code available on GitHub? Not yet, but please, if you're interested, follow me on Twitter and I'll post it real soon. Another question, how would you use Redux to store the data coming back from GraphQL for use in sibling or other components? Good question. So you can use Redux and you can hook up so Apollo has its own cache. So by default, Apollo uses its own in-memory cache, but there are adapters for you to hook your Apollo client up to Redux if you want to do it that way. But what I can do is if I write this user query, if I use this query in another component, if I use this query in another component, what I can do is I can tell Apollo to fetch the cache data first and then go and make the query again to fetch the most updated data, or just use the cache data. So instead of duplicating my logic in Redux again, I can just use the Apollo cache to fetch my data using GraphQL, even if it fetches it from the cache, right? Another thing I can do is if I have a component, so our to-do item component, right? So in our to-do item component, we've manually typed what we want to come in. So we've typed that we want complete and we've typed that we want label to be passed in. But if I want to say that for this item component, I want specific fields from GraphQL, I can create what's called a fragment. So I can define a new fragment. I'm going to call it item data, and the fragment is going to exist on a to-do object, right? And on this to-do object, I want to pull complete and label. And I can then type gen this, right? So I can type gen this data fragment, and I can replace my manual typing here with the types that are generated here. And again, what I can do is and if I don't want to have to like repeat myself here with the data that is needed by another component, I can pull in that fragment over here. So that's going to pull in the exact fields that I need for a child component, which I can then pass in. So what's cool about that is you can not only collocate all your logic, your markup, your styling, but you can also collocate your data requirements in one file. Do you have existing APIs that GraphQL runs on, or is there some mocking in the background? So I think this question means what do I have running in the background here? Well, I just have a very simple server setup using Nexus and Prisma. If you want to check out some really cool innovation that's happening in the ORM world, check out Prisma. It's basically what I have. I can show you how everything's defined here. Basically, I just have a query. I have a GraphQL query. This is not how we do things in production, but here I just said that I have a query field that is a user type, and it takes in an where argument and returns a user. And then I have my mutations. So this is just a very, very simple server setup, but we actually use a package called type GraphQL to define our GraphQL schema, and we actually define our GraphQL schema using TypeScript. So on the server, we have TypeScript that translates to GraphQL, and then that GraphQL gets translated to TypeScript again on the client. So it's typed full stack. That's all from my side. Thank you, everyone. It's a bit different doing a talk over Zoom, but yeah, I hope everyone enjoyed it and Hope it was as useful as it would have been if it was in person. And yeah, stay safe and be well, everyone. And yeah, check me out on Twitter if you want to see the open source, the code on GitHub and the blog post that will come real soon. Thanks.